it's not in one dimension, so F net and A, they will be vectors. So if your F net is the summation of several vectors, okay, like F1, F2, F3. In this case, you have to do the vector summation. So you have to do the decomposition step. And from the vector summation, the instance of the vector summation, we know that whenever you are dealing with one vector equation for a 2-dimension, that means you have to deal with 2 component equations. Okay. So F net x equals to MAX. F net y equals to MAY. So what happens is that the acceleration along x direction, AX, is totally determined by F net x. And FAY is totally determined by F net y. So there is no mixing. So F net x wouldn't affect AY. And F net y wouldn't affect AX. Okay, so you can deal them separately. And if you want to get like the total acceleration, then you need to combine the AX and AY in the vector rule. Okay, so basically it means you have to do square root of AX squared plus AY squared. And here, how do you get F net x and F net y? Okay, for example, if the net force is given by the summation of 3 forces, they can be in some arbitrary direction. Okay, so again, you know how to do that with this kind of problem. You have to decompose Fx1 to get F1x, F1y, and F2 is F2x, F2y, F3x equals F and F3y. So F net x would be the back summation of them, this x component, and Fy net y will be the summation of this individual components. Okay? But we are going to, so essentially, what we are doing is simply the vector summation. But we are going to develop some procedure suitable to this kind of problem. Okay, because there is no essential difference with our general vector summation. We try to add like A plus B to get some vector. There's nothing different with that. Okay, so now let's look at some example. What do you mean by this procedure? Okay. Example 1. A box is put across a frictionless floor by a pole erected 30 degrees above the floor. Write down the Newton's second law for the box. Okay? So again, you have to draw the diagram for the object and identify all these forces acted on. Okay. So the picture should be something like this. You have some ground, and a force is acted on the object with 30 degrees. Okay. Now we want to write down the Newton's second law for this object. Okay, do you remember how to write down Newton's second law? Is that F equals to ma, it's just this. Okay, but that's just general equation. You have to be applied this general equation to this particular situation. So you need to find out all these forces acted on. Okay. So how many forces acted on this object? You consider all the possible forces from all the directions. Can you count how many forces do you have?
3.
So 3. Let's check. Do we have 3? Okay. First, of course, this given pulling force F. That's 1. What's next?
Gravity.
Okay, the weight or the gravity, we can call it W. Okay. Anything else?
The normal force.
The normal force from the ground, so it's a supporting force from the ground, N. Okay. So 3. Do we have any other force?
Frictionless.
It's frictionless, so we don't have frictional force. Yes, we have only 3 forces. Now, okay, the Newton's law in the vector form, it could be written as F plus N plus W equals to MAF. Okay. But this equation itself, please note that this equation I will give parentheses because itself wouldn't give you any result. Because the 3 forces here, F and W, they are not in the same direction, so you cannot deal with them directly. So when we say to write down the Newton's second law, we're not saying to write down this meaningless vector form. Okay. We have to write down the component form. So now let's check how can we write down the component form. To write down the component form, of course, you have to decompose all these forces. Before you decompose all these forces, you have to choose some coordinates. In this case, of course, you can choose some coordinates like this. Okay, positive x, positive y. Okay, in other problem, you need to consider what is your best coordinates. For this one, okay, it's straightforward. You want to do this. Okay, now, then let's decompose these forces to get all the components. Okay? N and W, the decomposition should be simple because they are already along x direction, y along y direction. Okay. And then you have to decompose F to get Fx and Fy. Okay. Again, with the angle here, you should know how to do that. So now, so the decomposition should be written like this. You have 3 forces. So you should get F, X, F, Y, W, X, W, Y, N, X, and N, Y. In principle, you have these 3 forces, so you totally 6 components, right? So Fx, how do you express Fx? What's Fx? Okay, so it's F cosine 30. This is F sine 30. Don't forget to check the sign. So both of them will be positive, right? And Wx, okay. Of course, we know how to calculate W. Okay. It's mg. If we know the mass of the object, it's F. So Wx should be mg. Is it?
Mm-hmm. 0.
No, negative mg. Okay. Oh, sorry.
Was it 0?
Wy equals to negative mg. And Wx equals to 0. Right? Because this force is along negative y direction, so Wy equals to negative of this force, and Wx equals to 0. Nx, what's Nx?
0.
0. And Ny?
Just positive mg.
Positive mg. Please note that you don't have this kind of equation. Okay? N is not the same as mg. N may or may not be mg. The equation you have is W is always mg, okay? But this one is questionable. Please note that. N, you don't have some expression to calculate N by definition. N has to be calculated from some other condition. Okay, in fact, it's calculated from by solving the Newton's second law. So N is just Ny equals to what? N here, right? If you don't have X components, the Ny is just all magnitude of normal force N. And now, if you get these components, Okay, now you can easily write down the Newton's second law along x direction and y direction. Along x direction, that would be, okay, if you have the three forces, would be this plus this plus this. Together give you MA, right? So here, you should get x direction to be F cosine 30 equals to MAX, right? Newton's second law. And y direction would be the three forces together to give you MAY. So you get F sine 30 degree minus mg plus n equals to MAY. Okay. So that will be the Newton's second law for this problem. So when we say we try to write down the Newton's second law, we want to write down the two equations here. Okay? Any question how do you write down the two equations so far? Okay, we make the plot, decomposing the forces, write down the equations. Okay? It's basically just vector addition combined with the Newton's second law. Okay, and then for every problem, that's physics you are going to do. After that, you are just simply put down the numbers to calculate quantity. For example, if in this case I tell you what is the pulling force F, then you can and what is the mass of the object, then you can calculate all other quantities. Okay? And another thing we would like to mention here is that this is a general equation. Sometimes you can do one further application by identify a further simplification, by identify some property of the acceleration, okay, from the observation of the motion. For example, if I say this pulling force F wouldn't pull it up, the object is still moving along the floor. Okay? If you know the object is still moving along the floor, what do you know about AX and AY? They are the same? No? Think about if this object is moving along X direction without any motion along Y direction, what do we know about the AY? Zero. So in that case, so if the motion is along X direction, okay, in this case, so we should know AY equals to 0. Okay. So that's some hidden condition for you. If AY equals to 0, what do we know about AX? We wouldn't get value, but AX should be the same as the magnitude of the acceleration or the total acceleration A, right? If AY equals to 0, because A is always AX squared plus AY squared. So if AY equals to 0, A has to be the same as AX. If AX equals to 0, AY has to be the same as A, right? Okay, so that's also some very useful analysis. If you substitute these two, then the two equation becomes F cosine 30 degree equals to MA and F sine 30 degree minus mg plus n equals to 0. Okay? But please note that this is a special case of this general equation. It's true only if AY equals